In this video, we'll talk about covalent bonds. So covalent bonds are different from ionic bonds. So bonds are what hold atoms together to form molecules. In ionic bonds, we saw that there was a transfer of electrons from one atom to the other. And then the Coulomb's law of attraction brought them together. In covalent bonding, instead of electrons being transferred, electrons are shared. So I'm going to remind you of something we've talked about before, this diagram here. So if we have two atoms, they will be attracted to each other because the electrons from one will be attracted to the protons of the other. But there'll come a point where they'll reach an equilibrium distance, and that's where the attraction between them will be completely canceled out by the repulsion between the protons from both nuclei. So right at this point, there's going to be no net force. But you'll see that if we tried to push them closer together, they would repel and come back. And if we brought them further apart, they'd attract and come back. So they're at a place now of really low potential energy, which means they're stable, and they're stable together in this one unit. And so here's my little picture. I've got two oxygen atoms. The dots are representing kind of, again, where the electrons are most likely to be. It's kind of a rough sketch. And if I put them far away from each other, they'll naturally start being attracted to each other. And they'll stop at this equilibrium distance. But the important thing to see here is that they're now sharing electrons. And we're saying that, okay, these two oxygen atoms are really stable here, and these shared electrons are kind of keeping them together in a way, right? They're kind of being mutually attracted to each other, but they're at that equilibrium distance, so they're not going to get any further or closer. If we look at kind of the stability of electrons now, at individual electrons, we can go ahead and look here. So here I have two hydrogen atoms. Here's one hydrogen atom in black. Here's its one electron, it's 1s1. Here's another hydrogen atom in orange. Here's its 1s1 electron. Now if I bring them kind of close together, they'll attract, they'll go to the equilibrium distance, and just like down here, they'll share their electrons. And these electrons are kind of in between both. So we can say that each hydrogen has access to not only its electron, but the electron that's being shared with it. So this is kind of a, this even sharing, it's one for one. So now each hydrogen has access to two, right? This hydrogen, it's like how many electrons do you have? It's like, oh, two, these two here. This hydrogen, two, these two here. This is a covalent bond, right? Because now electrons are being shared, and then that's holding them together. So you'll see that now that both hydrogen atoms have access to two electrons, they now have the electron configuration of a noble gas, helium. They are now in their most stable electron configuration, 1s2. And we write this as H subscript 2, because there's two of them. Another way to write this is like this. Instead of writing the electrons out like this, you can draw a single line to represent a pair of shared electrons, right? One from one from the other. If we look at a different example, a common one, this is water, H2O, H2, because there's two hydrogens, and one O, because there's one oxygen. Each hydrogen now is going to form one covalent bond with the oxygen. So this hydrogen will share its electron with oxygen. Oxygen will in turn share an electron with this hydrogen, and same for this one over here. That gives both hydrogens access to two electrons, right? Because they have their own plus one being shared by, from the oxygen atom. So both of these hydrogen atoms have now reached a really stable electron configuration. If we now look at how many electrons the oxygen atom has, it's got its 6, 1, 2, 3, 4, 5, 6, but now plus 2 from the hydrogens. So now it's got 8. So now it has the electron configuration of a noble gas. And just so you can see two other wrinkles to this, there's a double bond in which each atom will share two electrons, right? So now two oxygens can bond to each other, and each one's got access to 1, 2, 3, 4, 5, 6, 7, 8. You can also have a triple bond in which three electrons are shared by each atom for 3 pairs. So these two nitrogens will make N2, and you can see that each one has access to 1, 2, 3, 4, 5, 6, 7, 8. And just to show you something cool, you can also have rings, right? So here are double bonds and single bonds, but if you count them up, it all works out.